Welcome to Concept 13D, identifying zeros and their multiplicity. And there are three boxes, so let's begin with box number 1. And box number 1 is all about some vocab. So we need to understand, what does a zero with multiplicity of k mean? Like, for example, k. So k is going to be some kind of a number, all right? So what I've done for you here so far in this little chart is I have created a bunch of polynomials, okay? So this one over here in the top left is, this is x minus 1 to the first power. This is x minus 1 squared. This is x minus 1 to the third, x minus 1 to the fourth, the fifth, and sixth, okay? So what we're going to do is we're going to look at these, the graphs of these, and look for similarities, okay? So here is the graph of f of x equals x minus 1. And you'll notice that one of the zeros of the graph is, of course, 1, because when I plug a 1 back into the function, I get 0 out. So 1 is a 0. X minus 1 is a factor of this, because this could always be 1 minus this. And notice that the 0 just passes right through the 1. So it just passes right here. Okay, no big deal. Now let's take x minus 1 and let's square it, and look what we get. Okay? Again, let's look at the 0. Okay, the 0 is located at 1, because if I plug 1 back in, I get a 0. Okay, so you'll notice that when x minus 1 to the first, it crosses through at 1, and at x minus 1 squared, it bounces and turns around at 1. Okay, let's look at x minus 1 to the third. Let's take a look at this one. Again, let's identify the 0. The 0 again is at 1, but it passes through. It does get a little flat around the 1, but it does pass through. Okay, x minus 1 to the fourth. If we take a look at this, notice that, again, the 0 is located at 1, but it's not quite as neat as a squared. It bounces and turns around at 1. Okay, x minus 1 to the fifth. Take a look at this one. Again, we know that the 0 here is located at 1, and it passes through, and it's a little bit flatter than x minus 1 to the third. And then this last one, x minus 1 to the sixth, looks a whole lot like x minus 1 to the fourth, except it's even a little flatter around the 0 of 1. Okay, so hopefully you guys are picking up what I'm putting down here, is that when you have an odd exponent like 1, 3, and 5, you'll notice that the graph passes right through the 0, but on an even exponent like 2, 4, and 6, you'll notice that the graph turns around at the given 0. This is called multiplicity. So this one, the 0 has multiplicity of 1, this 0 has multiplicity 2, the 0, 1 has multiplicity 3, multiplicity 4, multiplicity 5, and then multiplicity 6. So the whole idea about multiplicity is whether or not the function is going to pass through that particular 0 or turn around at that particular 0. The bigger the number, the flatter and wider around the 0 the graph will become. Okay, so this example is going to illustrate how we can find the multiplicities and their zeros. So right now, I have a function. It's 1/3 times x plus 2 all squared times x minus 4 to the fifth. And this function is in factored form, meaning it's not been multiplied out. So I can see right away that negative 2 is going to be a 0, and negative 2 has a multiplicity of 2, so it's going to turn around at negative 2. I can see from x minus 4 being a factor that positive 4 is a 0, and it has a multiplicity of 5. So at x equals 4, the graph is going to turn around. At x equals 4, the graph is going to pass through. So here we go. Here's the picture of this graph that I have graphed for you. And let's take a look here. At negative 2, you can see that because I have an even multiplicity, the graph is turning around. And then at positive 4, because I have an odd multiplicity, the graph is passing through. Now because 5 is a pretty large number, it's pretty flat around the 4, but yet it still does pass through the function. So when I'm talking about the zeros, I'm talking about where the graph is going to cross or touch the x-axis, and the multiplicity is going to let me know whether or not it's going to pass through that particular 0 or turn around at that particular 0. Okay, here is a u-try. It's like a partial u-try because I filled in some of the information, and you're going to fill in where this little arrow is here. But let me explain the setup. So I have a function, and the function is negative 5 times x plus 3 squared times x minus 6 to the third. Okay, I have listed the two zeros for you in this column. So from this factor, I can see that negative 3 is a 0. The reason is because if I plug negative 3 back in, I would get a 0 out of that, okay? And because the multiplicity is a 2, I can see up here in the exponent, because it's even, it's definitely going to turn around. Okay, now take a look at this one. The other 0 I have from this one right here, x minus 6, that means that 6 is a 0, because when I plug a 6 in, I would get 0 back, because 6 minus 6, of course, is 0. The multiplicity is 3, because I have an odd exponent, so you tries to tell me, will the graph turn around, or will it pass through? Hopefully you guys got the right answer. Of course, it will pass through, or it will cross through the x equals 6, because the multiplicity is odd.